Okay, infinite limits still fail to exist. This is AP Calculus AB. We're asked to evaluate this thing twice. We're asked to evaluate the limit as 3 over x minus 2 as x approaches 2 from values less than 2. That's what this means here, less than 2. Not negative, but less than 2. And the limit of 3 over x minus 2 as x approaches 2 from values greater than 2. So what we find out is that this thing has this weird looking shape. It looks something like this. Let's take a look at this for a second. Let me show you what it looks like, and then I'll explain why we're going to get this weird limit, but what we really are going to get is the limit failing to exist. So it looks like this. It looks like this. As x approaches, let this be 2 right here. As x approaches 2, from the left-hand side, this thing goes like this, and then it dives down here like this. And as it goes the other way, as it approaches 2, it dives this way. So this is what we're doing. As we're making this approach, we're saying as x approaches 2 from the left-hand side, that's this side, as x approaches 2, it gets pushed down. It's asymptotic to x is equal to 2, and it goes towards negative infinity. As we approach 2 from the from the right-hand side, that's here. As we approach this way, it gets pushed up, and x approaches positive infinity and negative infinity. So what I hear people saying, they say, "Oh well, Professor, the limit approaches negative infinity from the right-hand side and then positive from infinity from the left-hand side." That's true, but the limit still fails to exist. The limit still fails to exist, and let's look at why that's true. Remember, if a limit exists, then the limit of f of x as x approaches c from either side approaches L, where L is some real number. Well, let's look at what happens when we take a look at this. So I set this thing up as a table, and I put in these values. I set up my f of x as 3 over x minus 2, and then I approach from the left-hand side from values less than 2, and I got the negative 30, negative 300, negative 3,000. It's not approaching a real number. It's getting infinitely small. So I was like, you know what happens if I approach from the other side? Well, as I approach from the other side, can I switch this value out, please? This value should have been 2.1. As I approach this, as I get closer and closer to 2 from the right-hand side, I go from 3 to 300 to 3,000. It's not approaching a number L. It's approaching an enormously large number, otherwise known as an unbounded value. So this limit fails to exist. So you're going to see this people are going to say, oh, the limit as x approaches this value approaches infinity. The limit still fails. All this is an explanation of why the limit fails. So let's go back to this and be clear about this. Why does the limit fail? Why does it fail? Because it approaches an unbounded number. Infinity is not a number. Infinity is an idea. And so is negative infinity. So let's be clear about this. The limit here fails to exist. The fact that it goes to positive infinity and negative infinity is only a description of why it fails. So be sure that the equal sign of the statement f of x is equal to infinity doesn't mean that the limit exists. On the contrary, it tells us how the limit fails to exist by denoting the unbounded behavior as x approaches that value from either side. So let's be clear, the limit fails to exist. This is only a description of why the limit fails to exist. So I hope this is really helpful to you, because if you're taking the AP exam, they're going to give that to you. They're going to say, the limit approaches infinity. It does approach infinity, but if they give you the limit fails to exist, it does fail to exist, and that's the description of why it's true. So I hope this was really helpful to you. If you haven't already subscribed, please subscribe.